Hey, so I thought I'd make a video. The spreadsheet you sent me, there was a lot of mistakes on it, so I think I'll give you a better idea of what to do in this video. Okay, so I took away the plots. All right, so first of all, let's do the time versus position, or sorry, position versus time. Position should be on the y-axis and time should be on the x-axis. So here I'm gonna click on position. I'm gonna control click. Well, on a Mac it's command click, but for you it would be control click or shift click on time second, and then I'm going to insert a scatter plot. Okay, so right here we'll go to scatter plot. My computer's slow for some reason. Anyway, and here's the position versus time graph. Okay, so you can always check that you've got the right thing on the right axes by kind of coming down here and seeing what it says on the first point. See? And so this says it's like 0.03. That's not the first point because you can't really zoom in, right? And then 0.0038. And you can see that's this point right here, right? Because I'm just not able to click on the very first one or to hover over the very first one. But you can see that the time is on this axis, right? On the x-axis. Here, go back to where's our... Anyway, I can't get back to that point. Anyway, so you can see that the time is actually on is the first value x, y, right? And then here. So we know that's right. Okay. Now, the next thing I'm going to do is get a trend line. And I'm first going to just add a trend line. I just right-clicked on one of the points. Now it's slow and it's putting in a linear trend line. That's not what I want, right? I want it to be, because I know that the equation is x equal 1/2 at squared, right? Plus blah, blah, blah. Look in the lab manual. And I'm going to do polynomial with order 2. That means it's going to be time squared will be the highest order that's in there. And I'm going to display the equation on the chart. Takes a little while because my computer is really being crazy. All right. And then I'm just going to move it over. Again, that takes time. Okay, so what do we get out of this chart? So we see this is that 0.405 is 1/2 of the acceleration, right? Because that's what the equation is, right? X equal 1/2 a t squared. And remember that x here is t and y is x. It's weird, right? I wish you could make it actually use the variables you want to. But I'm just going to make a note here that, I'm going to use an equation that we have 2 times 0.405 as our acceleration, okay? And I don't want it to round, so let's see if I can make it. Let me just expand it. It probably won't round if I expand it. No, I don't know. Well, it's annoying that it rounds it, but you can figure that out later. All right, so this is acceleration from position, or no, x versus t. Okay, cool. Let's go on to the next one. So that's just the velocity versus time. So I'll click on velocity and then command click for me. On Windows, it's probably control click. And I get 2 of them on there, and then I go and insert a scatter plot again. Okay, so here we go, scatter plot. Again, it takes some time because my computer's stupid. And I'm going to put that up here, okay? And then the next thing is going to insert a trend line. Okay, add a trend line. And this will be a linear trend line, as you can see, right? It should be, right? Because V is equal to AT plus V0, right? And our V0 we're assuming is 0. And you can see it's really not 0, but that's fine. And then a display on the equation on the chart. Takes a while. And as you can see, my acceleration here, which is the coefficient of x, is 0.8033. Yeah, which is close to 0.8, right? Okay, so now this is the first thing that I can do. I can do statistics on, because for the quadratic fit, I'm not going to do statistics. So, but on any of the linear fits, I can do statistics, right? And remember that we're going to be calling the acceleration from this guy our accepted value. So our accepted value is going to be 0.81. Okay, here, so we have the velocity versus time. This 0.8033 is going to be one of our measured values. Okay, I want to do some statistics on this. So I'm going to use a linist. So remember that you're going to highlight like 6 things here, 6 cells. And then I'm going to start typing equal linest. Whoops, sorry, linest. Remember that it tells you what to do. You need the Y's first, not the X's. It's kind of weird that the X's don't go first. I don't know what to tell you about that. It's just Excel. So I'm going to come over here and grab all the velocities, which are in the y-axis, right? That's what's being plotted in the y-axis here. All right, so we're going to go all the way down. And I believe it's in this data 134. We're just going to grab all those. And then I put a comma. And then the next thing it wants is the known x's here. And that'll be time. And then we're going to go all the way down again. And grab, and you could type this in, right? Because now you know it's 134, line 134. Okay. And then I'm going to put comma 1, comma 1. You can see it up here. This is where I'm typing. Okay. And now for me to get this to work, I think it's the same for Windows machines, but it's Control Shift Enter. And then I get all the numbers, right? Okay. So what is this telling me? It tells me the slope, which is my acceleration, right, is 0.8033, whatever. And it's telling me the standard error of the slope is 0.008816. Okay, remember to get the confidence interval. So I'm going to say I want the confidence interval for slope. And I'm going to make, this is going to be equal to 1.65 times the standard error, and then we enter that, and that is my confidence interval. So as I come over here, I'm going to make a little note that acceleration, and this is plus or minus CI, and remember I've got to round right. So if you look over here, I've got to round this to 1 sig fig, that's 0.01, right? Maybe you could argue it's 0.02 because you'd round this up to 5, this up to 6. Yeah, okay. I'll say it's 0.02. Okay. Now, because it's got 2 decimal places, right? I round my slope to 2 decimal places as well. So I'm just going to write it in, right? I'm just going to write it in. It's 0.80, right? Plus or minus 0.02. Okay, there we go. All right. Notice here that 0.8 plus 0.02 gives us this range, right? So in other words, this 0.81 is well within the confidence interval of here. So this is a good measurement according to my accepted value, right? This is going to be my accepted value. And it's a little arbitrary to call that the accepted value, but okay. So let's do the next thing. We're going to plot just acceleration versus time. Okay. And this is probably going to be the noisiest of the data. I mean, it's not going to be the best data at all because the acceleration, you know, it measures position really well. And then it has to like do a calculation kind of to measure the velocity. Then it has to do another calculation to get the acceleration because we're not taking it off of the accelerometer that's on the device, which is a whole different deal. We're just not dealing with that. So it's the most noisy. I should expect it to look not great. Let's try it. So we're going to click on this and then command click here. And then again, insert a chart. Come on, slow computer. Okay, and we'll come that down here. All right, now you can see this is what this should be is a nice flat graph because this should be constant acceleration, right? But it's not. So it looks ugly and it's not going to give a great fit like at all. And you can see down here, these are part of the problem that it's going to skew the graph. The fact that it's kind of slanted is kind of the problem. So if you watch, we're going to add a tread line and it's going to be terrible. And you can just look at it and be like, that's bad. That's bad. And we'll display the equation on the chart. This is just going to be the ugliest of all the things. Okay, so this is ugly. I'm going to put this up here. Okay. Now, give it a second. All right. So what we're after here is not the slope. It's the intercept, right? Because it should be like a nice flat line with the intercept being the actual acceleration, right? The average. Okay. But look at the intercept, it's 1.05. That's not very that close to 0.8, but let's do statistics on it, right? Let's do our statistics. So down here, I'll do the linest for this, okay? And we're going to put in our known y's first. That's the acceleration we're plotting on the y-axis. And so I know the range now is like row 2 to row 134, so I don't have to like actually select it, I can type it. So that acceleration is in G, so I have G2 to G134, and then my known x's are the times, which are D2 to D134, and then I'm going to go 1, 1, and then close parentheses, and then Control Shift Enter. And now here I've got it. Now what I'm after is the intercept and its confidence, well, and its standard error. So again, I'm going to write down here CI for intercept, and then equals 1.65 times the standard error, which is this thing. And there we go. All right, now over here, I'll write down acceleration plus minus CI. Okay, and so we get, all right, let's round. We're going to round our confidence interval down here to 0.09, right? That's, okay, 0.09. That's two things after the decimal places, 2 places. So my acceleration is 1.05 plus minus 0.09. Okay, there we go. Now let's see. I'm not good for doing that in my head, but 1.05 minus 0.09. That's 0. Oh, I did that wrong. One more time. Oh, yeah, that we're good, right? Because what we're looking for is if you take 1.05 minus 0.09 is 0.81 in that interval. And yes, it is, because if I take 1.05 minus 0.09, I get 0.04. And in the middle between 1.05 and 0.04 is definitely 0.81, right? So we're good. And the reason we're good is because this is just noisy, really noisy, and it got a big confidence interval out of it. Okay, last plot is the velocity squared, and it looks like that this spreadsheet has you don't need the sum, by the way. So let me, I don't need to fix it, but you can see here that this is the velocity squared over 2, and why? That is because, remember, the equation is velocity squared equals 2 times a times x, right? So dividing by 2 means that when you get your slope, it'll just be the acceleration. Okay, but we have to plot this versus position, not versus time. So I'm going to click on that. I'm going to command click on this, and I'm going to insert another scatter plot. Okay. Come on back. Can do it. Ah, it did right here. Okay. All right. Now, this should be linear, right? Because it's v squared is equal to v squared over 2 is equal to ax, right? That's the linear equation. That means that when I do a trend line, it should be a linear trend line, right? I don't have to change it to something else. So add trend line and display equation, taking its time, display equation. And let's see how we do. Okay, that's not too bad. It's not great, but it's 0.73. We still, which is not 0.8, but let's do the statistics and see if we're within a confidence interval of our accepted value, quote accepted, of 0.81. Okay, so here we go. Let's do our stats again. So equal linest, again, the known y's now are velocity squared, okay? So that is the h column, h2 through h134. My known x's are not time, but their position, which is E2 through E134, 1, 1. And now again, my Control Shift Enter. And now again, I'm off for the slope and its confidence interval. So again, we're going to get the confidence interval, CI for slope. And this is going to be equal to 1.65 times the standard error. And there we go. And then when we round it, we're going to come up here. We're going to say acceleration plus minus CI. And okay, when I'm rounding my CI here, it looks like I'm going to be rounding it to 0.01. Okay, which two decimal places after the decimal. And the slope is here, right? Oh, did I do the wrong one? Let's make sure. U, did I do U? What's U? Which one's U? It's hard to tell which one's U. Let's just do it again just to make sure I didn't do the wrong intercept or the wrong standard error. So let's do equals. Actually, I can come up here, just get rid of this and just make sure I'm clicking on the right thing, which is here. Okay. That's better. Okay. I don't know if I did the wrong thing. I can't remember if this was the same number, but anyway, we're rounding it to 0.01. Okay. And now we come over here and this has to be rounded to 2 decimal places. So 0.73. So we're going to say this is 0.73, oops, 3 plus minus 0.01. Okay. Now, if you add 0.01 to 0.03, you do not get 0.8. So this one didn't work so great. And it's just noisier. And when you square stuff, you get noisier data. We can also double check that we're actually getting the right thing. And yes, we are, right? Because the position starts at 0.00233 and the velocity starts at 0.005. So we do have the right thing on the right axes. And so this one fails, right? This one was good. This one was good. And that's your accepted value. Okay, well, I hope that helps figure out what to do. And yeah, good. All right. Well, good luck. Got to stop the recording. There we go.